When we have some packet that is in the network in flight, then it's the job of the routers to take that packet and send it on in the right direction. So coming full circle, now that we know more about how those addresses are managed, and looking more in a router, how is it actually going to do this? That is, the router needs to receive a packet on one or more interfaces, and it needs to send it back out on one or more interfaces. And at this level, these interfaces are sometimes called ports. So a router has multiple input ports and multiple output ports, but this is a different word for it than the port number. It's referring to the different input and output interfaces of the router. The router then, for the purposes of one packet, wants to connect some input port to an output port, or deliver a packet along that path, and the software and hardware that does that on the inside of the router is called the switching fabric. And it does need a table to do that, but now we realize that this table doesn't have to list every possible internet address. It can list internet prefixes, and then send packets with those prefixes out to the right destination port. So packets that match the prefix 155.98.68.0/23, all of those are going to be delivered to 4. So that would be like the untrusted CS network in this example, and so on for other prefixes. Sometimes multiple prefixes in the table can match, and the order of entries in the table normally doesn't matter. Instead, the most specific match is picked. So if you have a 155.98.68 packet, it will match this one and this third one, the 155.000/8 prefix, but it matches this first one more specifically. That is the general idea, at least. This router has some other jobs. It may queue some packets. It may use a priority queue to give packets priority one reason or another. It may even inspect the packet in different ways and more deeply than just the destination address. This simple kind of routing table that I've described with prefixes, that goes by the name of a forwarding table. That's the basic, baseline, normal way of doing routing, but more complicated things that might take into account the kind of traffic, whether it's TCP or UDP, or some other fields in a TCP packet looking at the transport layer instead of the network layer. Those more complicated rules are often called a flow table. And when you start talking about flow tables, often you are in the realm of software-defined networking, where whoever is configuring this router is writing in some sort of programming language to describe these more complicated flow rules. So all of that is possible, but mostly we think about forwarding tables and these address-based routing schemes.